Okay, hey guys, so we're going to be solving question 12, and so we're just going to be proving that the left side is equal to the right. So with 12a, we're starting with a, and then we have AND gate, and then B and C complement, and that's our premise. So what we're doing is we're going to distribute the complement, and that's going to be using De Morgan's. So that becomes B complement, and then every time we use that, we have to flip our signs, and then we get C complement. And then all we're going to do now for the third step is we're going to distribute the A. And then that's the distributive law. And we can see that that matches up over to our right side. Now for B, we're starting off again with our premise. And again, we're going to use De Morgan's to distribute just within. So we get A complement, remembering to switch our signs, B complement. Again, with the distributive law with B now. So we get B and A complement, or B and B complement. And right here, if you have B and you also have B complement, that's null. So that's how we get to this step right here. And then now we're going to be using the associative laws. So basically just distributing this A to B and A complement. And then that's how we get our step 5. And again, we know that A and then having another A complement, that gives us null. So therefore, whenever we have a null and a null, or whenever we have like, I don't know, like a definition right here, and then we know we have a null, then everything is therefore null. Okay, now for 12C, what we're trying to prove is that it's A. Let me bring it over actually. So this is what we're trying to prove, just so you guys can see it better. So we're starting with our premise. And what we're going to do is we can just distribute the B complement. So we get B complement and A, or B and B complement. And this is actually, whenever we have B and B complement, so not an or statement, we get the universe, so U. And this simplifies down to basically B complement and A. And then we can rewrite that using the associative laws as A and B complement, because those are equivalent statements. Now for part D, again, starting with our premise, what we can do, we can rewrite this statement, B minus C. What that's saying is that's B, what that statement really says is B without C. So without C means C complement. So that's why I rewrote that as B and C complement. And now what we can do on step 3 is we can distribute the A. And that leads us down to step 4. And then so now that we have that all distributed, what we can do is we can kind of play around with our complements. So we kind of just put this complement outside, and if you actually distribute it, so that A complement turns to A. So these are all equivalent statements, we just moved the complement outside, and remember we have to switch our signs. And then what this is basically saying is this is C. Let's rewrite this outside like this. So A complement or C complement, or and C complement, is equal to this by associative laws. And so what that is saying is that's C without A. So that's why I wrote it like this. And then again, keeping track of our complement, right? So that's going down here. And then that complement can basically be saying, if we kind of look at this, so we can look at A or B, and you can kind of look at it like this, where it's basically saying A or B without the complement. So that's why you put the minus sign, because it's saying without this guy, without C minus A.